Hi, my name's Naveen, and today I'm going to be talking about my tape lab. So, introduction. The purpose of this lab was to explore static electricity and determine the charge on pieces of tape that were given a static charge. These pieces of tapes are charged using the triboelectric effect, which just is a transfer of charge due to friction between two surfaces. The physics principles involved are Coulomb's law, the law of conservation of charge, and Newton's second law. So, observations, data collected. When I brought two U-tapes close together, they repelled each other. This proved that they both had the same type of charge. So from this observation, we know that they are both positively charged or that they are both negatively charged. And then further testing with a negatively charged pen. So for context, we created the negatively charged pen. I created it by rubbing against my head. I used a Sharpie, and when I brought it near the U-tape, it was attracted to the pen to the Sharpie. So that proves that both the U-tapes are positively charged. So the floating experiment observations. So when I tried to, this is the observations from when I tried to when I floated one of the U-tapes above the other. Both U-tapes are about 7.8 inches, which is 0.19812 meters. Using the constant given in the lab, the mass of both pieces of tape was about that number of kilograms. The distance between the pieces when the tape started to float was 0.034 meters approximately. So the calculations for this part of the experiment. The givens are the mass of the tape and the distance separating them when the floating tape is at rest. Since the object is at rest, the net force is 0 and Fg and F electric are equal in magnitude. Now, after that, you have to solve. So now, since you have this equation where F electric and Fg are equal, you just solve for Q by plugging in all the givens. To find the number of deficient electrons, I divided the total charge by the charge of one proton. So this number, 1.57 times 10 to the negative 8th coulombs, was the total charge on one of the pieces of tape. Total excess charge on one of the pieces of tape, and I divided that by the charge of one proton to find the number of electrons that are deficient, that are missing from the tape, that prevent it from being neutral. So I know it's deficient since the tapes are positively charged. That means they're lacking electrons. They don't have an excess. To find the ratio of electrons removed to total atoms, I had to find the number of total atoms in my tape. I used the square approximation and assumed that in a square with area 1e to the negative 20 meters, that there was one atom. So then I divided to find the ratio, I've divided the number of electrons over the total atoms in one piece of tape. And that was the number I got. So for my glow script model, I first loaded in all the initial conditions and created both pieces of tape in the model. So I just put in K, which is Coulomb's constant, the charge of one proton, which I don't think I used actually. I assumed that both the pieces of tape were point charges like the lie required us to. And then I put in the mass of the tape and J hat and G. Now I just found the gravitational force. And after I found the gravitational force, I found the distance between the positions of the tape 1 and tape 2. And then I found R mag, which is D in that equation. And now do you know that the magnitude of F electric is the same as Fg, so you can use this to solve for Q. Now some errors that were part of this lab that may have led to some strange results. One error was the amount of charge on both tapes was constantly changing because while there is human contact with the U-tapes, the hand is acting as a ground. This leads to constantly varying amounts of charge and error in the lab. So what if the electrons have positive charge and the protons have negative charge? What would change about the observations? The observations made with my tapes and other charged objects would not change at all. This is because the fundamental law of like repels like and opposites attract still holds true under this imaginary scenario. So even if the electrons had positive charge, they would still interact with other electrons in the same way. They would still repel each other, and they would still attract protons. So it wouldn't make a difference. Why is it important to handle the charge tapes as little as possible? Well, the U-tips in my experiment were positively charged. When they come into contact with my hand or other objects, electrons from my hand will go to the U-tapes to offset the potential difference between the two objects. So that's just charge flowing to where there is less charge to offset the potential difference. So the hand and the other objects will act as a ground.